Okay, assalamu alaikum and good evening or morning. All right. So this is from another question that one of your friends has sent to me, and we'll have a look at it. Okay. So let me just underline this right better. Sorry about that. So we have to determine the magnitude and the coordinate direction angles of the resultant force and sketch this vector on the coordinate system. So okay, we have a coordinate system obviously in Cartesian coordinates in terms of x, in terms of y, and in terms of z, right? The typical coordinate system. We have two forces, right? F1 100 newton and F2 200 newton, okay? And F2, as you can see, that it makes an angle of 45 degrees to the positive x-axis, 60 degrees to the positive y-axis, and 120 degrees to the positive z-axis. Whereas for F1, by the way, it makes an angle of positive 35 degrees to the z-axis and, well, 20 degrees actually through this line. Okay, so this line basically is when it's F1 100 newtons sine 35 degrees. Okay, so it's basically this is the sine component, and of course this is the cosine component, right? And later, of course, you can resolve it later with the 20 degrees, which I will show you how this is done. So the first way to approach this problem is to try to find um, the components in terms of fx, fy, and fz. Okay, so we have to find these three components, right? So that's the first the most important thing actually. Okay, then obviously we know that the resultant force, if you express it as a vector, the fr is just simply fxi plus fyj plus fzk. Okay, and whatever unit you want to use, I think we'll put in Newton. But let's find the individual components. We find the fx, we find the fy, and we find the fz. Okay, so how we do this, let's just break down each of the forces. Okay, let's start with force 2, right? Force 2. Okay, or let me just write force F2. I think it'll be easier for you to understand. So force F2, if you want to break it to its x component, okay, it's quite simply 200 cosine 45 degrees Newton. Okay, and if I am not mistaken, on the calculator we should get, okay, is this correct? Yeah, on the cricket. Right, you should get about 141.42 newtons. Okay, let me just double check this. Yes, so cos 45 is square 2 and 3 100. Just okay, yeah, it's right. Okay, and then of course now we have our f2 in the y component, so it's just simply 200 cosine 60 degrees Newton. Okay, which we should get 200 cosine 60, it's to be 100, so we got 100 Newton. Okay, and of course our f2 z component is just simply, wait, let me have a little more space to write this down. So f2 z component is just simply 200 cosine 120 Newton. Okay, so as we do it, I think we should get, okay, interesting, we get negative 100 Newton. So negative actually means it's going downwards. Okay, so if I were to emphasize, negative 100 Newton mean it would actually go this direction. It'll be 100 Newton. Okay, because we associate the positive z-axis in terms of going upwards, right? Similarly for the x-axis is going out of the plane, or I mean out of the paper actually, if you want to say it that way. And y-axis, you know, if it's going to the right, of course it's positive. If it's going to the left, of course we know that is negative. Okay, so we're done for force F2. Now let's break down force F1, okay, into its x, y, z components. So force F1, okay, let's put a colon. Okay. So let's start with the easiest one, F1Z. Okay. So F1Z is pretty easy. It's just simply 100 Newton cosine of 35, right? So 100 newtons cosine 35. So we should get 100 cosine 35. We should get 81 points. Let's just put 2 decimal places, yeah? 81.91. Shall I put in 2 decimal places? Okay. Or 3. I think we'll just put in 3 decimal places. It's no problem at all. 915 newtons. Okay, so that's F1 and Z component. Now, if you want to find the X component and the Y component, if you want to find in respect to F1X, right, and you want to find respect to F1Y, right, how are you going to do this? So we have to obviously find this component. Let me just put in purple, yeah, because I think it'll be easier. And this component is obviously F1 sine 35, right? This component right here is F1 sine 35 as we know it. And of course, we have the angle 20 degrees, which we can easily resolve into our F1x and F1y component. Okay, let me show you how this is done. So F1x component is just simply, as we mentioned earlier, is just F1 sine 35. So it's just 100 sine 35. Sorry, not sine, my apologies. Sine 35. And if we're talking about the x, we're resolving in x, so obviously be a cosine of 20 degrees, okay? And I'm putting in black, but you get the gist of it. So it's gonna be cosine of 20 degrees in Newton. Okay, that's all you have to do, really. And let me compute it real quick. Times cosine 20. Okay, we get 53.89. Okay, so 53.899 newtons. Okay, and for F1y, okay, it's gonna be 100 again sine 35. Okay, but since now we're interested in this side, so this side obviously would mean Fy would be obviously be sine 20. Okay, but do be aware, okay, since that F1x is actually positive, okay, because we're obviously pointing it to the positive x-axis, and F1z was positive as well because we're pointing into the positive z-axis. Fy here would become negative, okay, negative because the positive y-axis is actually this direction. So if we are going to the left, it will clearly be negative. All right, so with that being said, so I'm gonna make sure I put the negative sign. Sine 20 degrees Newton. Okay, all right, so negative 100 sine 35 times sine 20. All right, so negative 19.617. So negative 19.617 newtons. Okay, actually let me do something. Let me point a direction to be clear. So F2x clearly is going in that way. That's the positive direction. F2y is clearly going that way. That's the positive direction. And here this arrow will show that's going in the positive direction, but unfortunately it's showing negative. That means that it's, we know that it's let me just mark it down here, opposite. So opposite, in this case, is going downwards. All right, so that's why I put it downwards. Okay, the most important thing actually in this kind of problems is your sign convention. So this one obviously is going, sorry, put in black again, going upwards, right? It's positive. Here is positive, and here, as you can clearly see, is negative. Okay, again, that means it's opposite. We know that it's opposite. It's going left, right? So it's definitely going to the left, which is negative y. Okay, so with that being said and done, since we have already expressed the forces into its respective x, y, and z components, then we can easily add up to find the resultant. We can easily find the resultant x component, y component, and z component because they wanted to find the resultant force. Remember that for any resultant force is summation. Let me write down very clearly with red pen. Okay, red ink. The summation of the resultant force, the summation of all the forces, right, is equivalent to Fr, which Fr as we denote it as the resultant. Okay, so that's what we call the resultant. And this is indicating the sum of all forces. Right. Okay. So with that being said and done, let's find the fx component. So fx is just equivalent to f1x plus f2x. Right. If we do the addition, okay, so it's gonna be 53.899. Okay, I'm just gonna have to do the reckoning real quick. So 53.899 plus f2x is 141.42. So 141.42. Okay, so it becomes 53.899 plus 141.42. So it becomes 195.319. So 195.319 Newton. Again, the direction is the same because both F1x and F2x are positive. So therefore, the resultant will also be positive as well. Okay. So yeah, that's for Fx. Let me try to draw a border here real quick so that we don't get confused by the way. Okay, cool. So now Fy, okay, is obviously F1y plus F2y, my bad. F2y, okay. So F1y is negative 19.617 plus F2y would be 100, okay, so 100, okay. So how much would that be? Negative 19.617 plus 100 would be 80.383. So 80.383 Newton. And since it's positive, we know that it's going in the positive y direction. Okay. And last but not the least is Fz, which is simply F1z plus F2z. Okay. So it's just simply 81.915 plus F2z is negative 100. Okay, so it's negative 100. Alright, with that being said, how much do we get? 81.915 minus 100. Oh, sorry, minus 100 number. So it should get negative 18.805. Negative 18.085 newtons. So since it's negative, we know it's going the negative z-axis direction, which is downwards. Okay? So since we've already found the individual components of fx, fy, and fz, now it's time for us to create our resultant vector, and then we can easily find the magnitude and the coordinate direction angles. And later, of course, we can sketch this vector on the coordinate system very easily. Alright? So it's actually quite easy. Let's just find the magnitude first. Let's express it into the vector real quick. So the resulting vector is just simply Fr is equivalent to 195.319 plus 80.383 J minus 18.085 k 18.085 k. Okay, so that is your resultant vector. Alright, so the first thing we want to find is the magnitude. So magnitude is fairly straightforward. Okay, to find the magnitude of your vector is just simply you take all the components and square them. So 195.319 squared plus 80.383 squared plus negative 18.085 squared. Okay, so once that's being done, I think if you simplify the problem, 195.319 squared plus 80.383 squared and negative 18.085 squared. Okay, so yes, your resultant or your magnitude would be 211.986 newtons. If we take it to three significant figures, it would just become 212 newtons. Okay, so that's your first part of the answer done. Now the second part, actually, if I'm not mistaken, was to find the coordinate direction angles of the resultant force. You want to find the coordinate direction angles. That's your second part, by the way. Okay, so for coordinate direction angles, right, you want to find your coordinate direction angles. Coordinate direction angles. Okay, what we have to remember is that we're talking about the direction cosine angles. Okay, so we know that cos alpha, okay, is just simply your fx, okay, over the magnitude of the whole vector itself. Okay, your fr, the magnitude of fr itself. Okay, so fr vector, right? So your fx is 195.319, so 195.319 over the magnitude was how much? 211.986. 211.986. Okay, that was your cosine alpha, and your alpha would be what would be in this case? So your cosine, you take the inverse of cosine, right? So the inverse of cosine, 195.319 over 211.986. What should that be? Cosine 195.319, 211.986. How much should that be? That's about 22.9. So 22.9 degrees. Okay, that's your cosine alpha. Cosine beta, same thing, but instead it is your fy component over the resultant fr itself. So it's just 80.383. So 80.383, right, over 211.986. That's your cosine beta. Then of course beta is just the cosine inverse of 80.383 over 211.986. How much is that supposed to be? That would be about 80.383. Okay, 80.383? Yeah, 80.383. Okay, perfect. So it's supposed to be 67.7 degrees beta, right? So that's your alpha, and then that's your beta. Now for gamma, it will be cosine gamma fz over the magnitude of the vector itself. Fz, if I'm not mistaken, was negative 18.085. So cosine gamma is just negative 18.085 over negative 18.085 over 211.986. 211.986. So gamma is just the cosine inverse of this 18.085 over 211.986. What would it become? .94. Okay, so it becomes 94.9 degrees. Okay, so it's already clear that we've already found our alpha, our beta, and our gamma just now. Okay, so we've already found all these three. And now our next job is to sketch the coordinates of this vector. Okay, sketch the vector in the coordinate system. Okay, so for the sketch, it's fairly straightforward. Okay, you just do a rough sketch of the vector system, in terms of this. Okay, yeah, okay. So x, y, and z. Okay, and our force in question is 212 Newton. That's the magnitude, yes. So I'm gonna draw in blue color if possible, right? If you can draw in a different colored pen, like a blue colored pen, when you're drawing the force, it will actually be a bit easier to see. So it'd be something, because you also have to make sure the angle that you're drawing also makes sense. So in this case, our angle through the positive x-axis is 22.9. So this is with respect to x-axis positive, respect to y-axis positive, and respect to z-axis positive. So this is respect z-axis positive. Okay, so with that being said, let's just begin drawing. Right, so the force would be somewhere here, by the way. Okay, the resultant force. The magnitude of the resultant force, as we know it, will be Fr, is equivalent to 212 newtons. Okay, and then we have the angle. Okay, so here our alpha would be equivalent to 22.9 degrees, so 22.9 degrees. Okay, our beta, our beta would be 67.7 degrees. Okay, 67.7 degrees. And our gamma would be 94.9 degrees. Okay, so that's basically it. That's basically how we solve this problem, right? So we first obviously find the magnitude. Okay, when we got the resultant x, y, and z resultant vectors. And after we find the magnitude, obviously we find the coordinate direction angles, that alpha, beta, and gamma, right? Through these formulas. Let me just check first if the formulas I actually mentioned right. Real quick here. Yes, they're correct. Okay. And for gamma as well. Okay. Then for sketching, normally for sketching, they only just are interested in the vector itself. So you only just draw the axes in terms of x, y, and z, right? And then you just draw the vector itself. They're just really interested in seeing the resultant vector. You don't have to draw the whole structure, all right? They're not expecting you to do the whole structure and draw F1 or F2. That is obviously not needed. They only wanted the resultant, okay, as I've drawn here. And it will be nice if you were to use, let's say, a blue pen actually to draw the force, and black pen or maybe pencil to just sketch the axes, so it'll be easier for the examiner to see the axes, right? And also for you as well, it'll be easier for you in this sense. So yeah, hopefully this helped you, right, for tomorrow's midterm. And yeah, thank you so much. Assalamu alaikum warahmatullahi wabarakatuh.